Right now, over southern and central England, the same dome of high pressure that has sat locked in place for 19 days is finally starting to buckle, and the Met Office is watching a very different kind of warning light up the map. This isn't the story of a heat wave simply fading into a cool, pleasant weekend. What follows a heat wave like this one is sometimes more dangerous than the heat itself. Normally, your instinct here is correct. In most ordinary British summers, a heat wave breaks, temperatures drop by 6 or 7 degrees, a bit of rain falls overnight, and life goes back to normal within a day or two. That's how the atmosphere is supposed to reset. But this instance is different because of what's underneath your feet, not just what's above your head. And that distinction is the entire reason this transition deserves real attention rather than a shrug of relief. Let's start with the setup, because understanding the mechanism is what separates genuine forecasting from guesswork. For 19 days, a blocking high-pressure system has parked itself over the UK and northwestern Europe, acting like a boulder dropped into a fast-moving river. The jet stream, which would normally steer rain-bearing low-pressure systems through on a 5 to 7 day cycle, has been forced to divert north around it, splitting into 2 branches. Temperatures underneath this dome climbed as high as 34 degrees Celsius in parts of the southeast, and with almost no meaningful rainfall recorded in 22 days, the ground has been baking under that lid the entire time. That's the setup. Now that the block is weakening, the jet stream is snapping back southward, and it's dragging a moisture-loaded frontal system with it, straight toward ground that has spent nearly 3 weeks turning into something the atmosphere doesn't expect. Here's where the second mechanism comes in, and it's the one most people don't think about until it's too late. Soil that has been baked for weeks under extreme heat undergoes a process called hydrophobicity. The top layer, dried and cracked, effectively behaves like sealed pavement instead of absorbent earth. When gentle rain falls on healthy soil, it soaks in gradually. When heavy rain falls on hydrophobic soil, it simply runs off the surface, exactly the way water sheets off a car windscreen. This is the specific reason forecasters are treating this transition with more caution than a normal summer cooldown. The compounding danger isn't the heat, and it isn't even the rain in isolation. It's rain landing on ground that has temporarily lost its ability to absorb it, and that combination is what produces flash flooding rather than the slow, manageable runoff of a typical shower. Now for the scale, because vague warnings help no one. Current model guidance suggests parts of the West Midlands and South Wales could see between 40 and 70 millimeters of rain within a 6 to 9 hour window as the front pushes through, which in a normal month would be close to that entire region's average rainfall, arriving in less than half a day. To put that in perspective, 70 millimeters in 9 hours is roughly 3 times the intensity threshold the Environment Agency associates with surface water flooding risk in urban areas. But here's the honest caveat. Rainfall from convective, thundery frontal systems like this one is notoriously patchy at a hyper-local level. One postcode can receive 50 millimeters, while a town 8 miles away stays almost completely dry, and no current forecasting model, however sophisticated, can pin that down precisely more than a day or 2 out. This pattern isn't new, and that's actually reassuring in one sense. It's documented, not mysterious. In August 2020, a prolonged heat wave across southern England broke into severe thunderstorms that dumped over 60 millimeters of rain on parts of London within a matter of hours. Overwhelming drainage systems that had coped fine with far more total monthly rainfall spread out gradually. In July 2021, after weeks of dry, hot conditions, London experienced flash flooding so severe that 2 tube stations were closed and multiple hospitals had to divert patients due to water ingress, a direct consequence of hardened ground shedding water into a drainage network never designed for that volume in that time frame. And going back to the summer of 2018, one of the driest UK summers on record, several water companies issued hosepipe bans by late July, only for the subsequent breakdown of that high-pressure system to bring localized flash flooding to parts of Yorkshire within days of the ban being lifted. The through line across all 3 events is identical to what's unfolding now. Extended heat and drought conditions, followed by intense, short-duration rainfall landing on ground that simply couldn't take it in fast enough. So what does the range of outcomes actually look like? Honestly, rather than just the worst case. In the mild scenario, the front weakens as it crosses the country. Rainfall totals stay closer to 15 to 25 millimeters over a longer window. The ground absorbs what it can, and you get a genuinely welcome, if messy, end to the dry spell with only minor localized surface water. In the more severe scenario, the front maintains its current intensity and training thunderstorm cells repeatedly cross the same corridor, pushing totals toward or beyond that 70 millimeter mark in under 9 hours. Low-lying areas of the West Midlands near the Severn and Avon river catchments, along with parts of South Wales where valley geography concentrates runoff quickly, are the sub-regions forecasters are watching most closely for the severe outcome, precisely because the same hydrophobic soil mechanism compounds faster where water naturally funnels downhill into narrow valleys rather than spreading out across flatter terrain. It's worth being upfront about what forecasters genuinely cannot tell you right now. They cannot tell you which specific streets or postcodes will flood. They cannot tell you the exact rainfall total for any single hour in any single town 3 days from now. Convective rainfall is simply too locally variable for that kind of precision this far out. What they can responsibly tell you is the broad risk pattern, which regions have the combination of heat-baked soil and incoming moisture that historically produces flash flooding, and roughly, which window of hours carries the highest risk. That's the honest boundary between useful forecasting and false certainty, and it's worth remembering the next time a warning sounds vague. The vagueness is often the most truthful part of it. It's also worth briefly zooming out, with a clear flag that this next part is genuinely still being researched rather than settled. Climate scientists have observed, across multiple studies, that a warmer atmosphere holds more moisture, roughly 7% more per degree Celsius of warming, according to basic thermodynamic principles, which some researchers link to an increased tendency toward these compound heat-then-deluge sequences in temperate regions like the UK. This is an active and, in some specifics, debated area of climate research, and no single event like this one can be attributed to that broader pattern with certainty. It's context, not a verdict on this particular week's weather. So here's what you can actually do with this information, starting now, rather than once the rain has already started. If you're in a flood-prone property, put flood barriers or sandbags in place before the rain arrives, not during, because hydrophobic ground means water can rise faster than expected once heavy rain starts, leaving far less warning time than a normal rain event. Keep an eye on Met Office and Environment Agency flood alerts for your specific area over the next several days, since localized warnings will update faster than general forecasts as the picture sharpens. Move anything valuable out of basements or ground floor storage in known flood risk areas, because fast onset flash flooding from runoff often gives less warning than slow-rising river flooding. Never drive through moving floodwater, even water that looks shallow, since it takes as little as 30 centimeters of moving water to float and sweep away a car, and hydrophobic soil flash floods often carry surprising force for their apparent depth. If you have elderly or vulnerable neighbors, particularly anyone in ground floor flats near known drainage pinch points, check in with them before the front arrives, not after. And keep a torch, a charged power bank, and any essential medication accessible, in case localized flooding briefly disrupts power or access to your street. The real lesson underneath all of this is that the end of a heat wave doesn't mean the end of the weather risk. It means the risk changes shape. The heat itself, brutal as it was the visible danger. What comes next, the ground's temporary inability to absorb what falls onto it, is the invisible one. And it's exactly the kind of transition that catches people off guard, precisely because it arrives disguised as relief. If you want to catch these pattern breakdowns before they escalate, rather than after the warnings are already flashing red, that's exactly what this channel tracks. So consider subscribing for the next one, because more often than not, the storm after the heat has more to say than the heat ever did.